Hello students, welcome to my next YouTube class. So here I am with a new unit of section B, that is electromagnetic waves. So before going to the topic EM waves, that is electromagnetic waves, so let's understand what are waves. Waves are the disturbance created in a medium which transfers its energy and momentum from one place to another. Okay, so make sure it may be sound wave, it can be light wave. Okay, in this type of waves, you see particles are not getting displaced from its original position. It only transfers energy and momentum from one place to another. Now if you consider a sound wave, in class 11 we have come across, in sound wave what is formed? Compression and rarefaction. So compression and rarefaction are formed in a region to transfer only the energy and momentum. Okay, the particles which are very closer to each other in the air, then compressions are formed. When the particles move away from each other, rarefactions are formed. So when compression and rarefactions are formed, you see they transfers energy and momentum from one place to another, but make sure the particles are not moving, right? So similarly for the light waves also. So you see EM waves. Now waves, when we say, there are two types of waves. One you can say as mechanical waves and electromagnetic waves. Waves which require a particle medium to travel for its propagation are known as mechanical waves. Electromagnetic waves are those waves which don't require any material medium to travel, right? So they can travel in vacuum as well, right? So what are EM waves? So EM waves are those waves which propagate in space through electric and magnetic field varying in space in time simultaneously, right? So here we see that these are those waves in electric field and magnetic field. They are perpendicular to each other and their motion is along perpendicular to the direction of propagation. So you see I have made one graph here. You see E, B and C. Okay, what is E? Electric field. What is B here? Magnetic field. And they are perpendicular, that means 90 degree to each other, and they are moving perpendicularly to the direction of propagation. So these are electromagnetic waves. That means they travel in a space in which electric field and magnetic field, they vary in time simultaneously, right? So what is the origin of these EM waves? These EM waves are produced by an accelerated or deaccelerated charge or by AC circuit. Okay, that is for LC circuit. Now let's see what are the characteristics of these electromagnetic waves. First characteristic said that they are in transverse in nature. Okay, and they travel with the speed of light. That is, what is the speed of light? We know that is 3 into 10 to the power 8 meter per second. So this is the speed of light, right? So point number 2, they are neutral. That means EM waves are neutral. They are not deflected by any electric field or magnetic field. And next, the EM waves, the electric field and magnetic fields, they are perpendicular to each other. That's already I told you, they are transverse in nature. Okay, so EM waves, electric field and magnetic field, they are perpendicular to each other and they are perpendicular to the direction of propagation. So these are the three characteristics. There are more characteristics, like in EM waves, there is always reflection, refraction, interference, diffraction. Okay, the ratio of electric field and magnetic field is constant, that is C. E by B equals to C. Okay, so there are many more characteristic, but these are the important ones. So this one also you note down in your copy. So EM wave shows the properties of reflection, refraction, interference, polarization, right? Point number 5, in EM waves, electric field and magnetic field, they are always in same phase. Okay, and the ratios of magnitude of electric field by magnetic field is also constant, that is of speed of light. Right, so these are the more three characteristics. So this one you will add in your copy. So these are the few electromagnetic spectrums. Okay, so in electromagnetic spectrums there are some waves are there, like there are gamma waves. Okay, there are X rays, there are UV rays, ultraviolet, visible light, infrared, there are microwaves and radio waves. Okay, So you see gamma rays, X-rays, UV, visible, infrared, microwaves and radio waves. You see the wavelength is increasing, as well as here you see in this side, that means here it is in this order, right? You see the wavelength is increasing or frequency is decreasing. So these are the different electromagnetic waves, and they have different properties as well as their production, their wavelength range, their frequency range. So I have noted few here, but in your book, whichever book you are referring, you will find there is a chart. You have to memorize that chart. Okay, in that chart you will find that, for example, gamma rays. Okay, how it is produced? That is due to decay of radioactive nuclei. What is the wavelength here? That is 10 to the power minus 40 meter to 10 to the power minus 10 meter. What is the frequency range? 3 to 10 to the power 22 hertz to 3 to 10 to the power 18. What are the properties of gamma rays? That is high penetrating power, therefore low ionizing power, and they are uncharged, that is neutral, right? So where they are used in medical treatment, and it gives the information of structure, that is nuclear structure. Next, X-rays. They are produced due to collision of high energy accelerated particles when they fall on a targeted metal. So when that high accelerated particle, when it falls on a metal, then X-rays are produced. Okay. So here wavelength range, frequency range is given, properties and application. So gamma rays, X-rays, microwaves and radio waves. So many times it has seen that questions comes from these four. Okay, but there are more, 3 are there, so that one also you will include in this chart. Okay, so refer your book and make one chart in your copy, and you will copy this one. So this type of question comes, right? So electromagnetic radiation with the wavelength. Now tell me that wavelength, what is that electromagnetic radiation that is used to kill germs in water purifier? What is that electromagnetic radiation that are used in TV communication? Okay, so you see electromagnetic radiation which is used to kill the germs in water purifier, that is UV rays. Okay, so radiation which is used in TV communication, that is microwaves. Similarly, which is used to treat muscular strain, that is infrared. Radiation which plays an important role in maintaining the Earth's warm, that means for global warming, for greenhouse effect, we use infrared. Next, the radiation produced in nuclear radiation, that is gamma rays. Okay. Radiation that are used to detect bone structure, X-rays. Radiation used in aircraft navigation, that is microwaves. And the radiation that are produced by bombarding a metal target with a high speed electron, just now we have seen, that is X-rays. Okay, so do remember this one and note down in your copy.